Today, I want you guys to figure out the answer to the biggest question I've asked all year. Okay? I've asked you little questions, right? What's an example of a little question that I think I've asked you so far? Aria? What forms of liquid? What forms of liquid? How does a vapor turn into liquid? Small question. What's a small question I've asked? Where does heat come from? Right? The sun. That's a little question. You guys know these little questions. You know what's another little question I've asked?
What is the first step of the water cycle?
What's the first step of the water cycle? Is there even a first step? Shrink. You guys, these are all examples of questions. You want to see it on the milestone. You want to see it on the test, right? I'm going to give you now a big question. Because when you get to college and when you get to high school, teachers stop asking little questions. They just assume you know them. Teachers instead, Anaya, start asking big questions that have big answers. So my question today, what are the big ideas that matter from earth science? If you had to explain to somebody, what was the most important thing you learned this year? What would it be? So just think, for 15 seconds, what's the most important thing you learned this year? Was it a certain lesson? Was there a video? Was there an idea? Does it connect different things? Think. Okay, now turn to your person sitting next to you and talk in a whisper voice for 30 seconds. Ready? Go.
He told me to.
Okay. What's the most important thing you learned this year?
Solar energy, and we also talked about like tectonic and
Where you were, in case of 4. 10 more seconds, we're back together. In 8, in 7, in 6, in 5, now we're talking in 4, in 3, in 2, in 1. So raise your hand, what did you and your group talk about? What is something that you think was the most important thing we learned? Duranda. So continental drift. What is continental drift? Okay, so maybe it has something to do with continental drift. That's one idea. What else are big ideas we've learned about? Mia?
the Big Bang Theory.
Big Bang Theory. What happened during the Big Bang Theory?
The universe was formed by at first it was nothing, and then it was a really slow thing.
Right?
And matter started to expand and colliding, and the universe was made.
Okay, Big Bang Theory. What else we got? Great ideas. I'm still looking for a bigger idea. Okay, well, I'm putting it over there that are going to help get us there. Ariel.
And where we get our natural resources from, and if they're going to run out, then where we get what.
Okay, so the idea about conservation. Right? What else? Let's keep going. Zion, what do you think? Astronomy. Well, that's a topic. That's not an idea yet. Be more specific. That's not. You think that's the biggest thing we've learned about this year? I won't push back on you on that. Okay, Jaden. Okay, maybe we're looking for Goldilocks planets, right? That have moderate climate, have liquid water, and oxygen. Taki, what do you think the biggest one? I'm looking for a bigger idea. We got Pangea and continental drift. What? Okay, let's see what this. Put your hands up for a minute. What are ideas that apply to geology, the layers of the earth? What are ideas that apply to hydrology, water? And what are ideas that apply to astronomy and optics? What that connects all of them? Bria?
The sun, when we were talking, she was talking about plate tectonic, and I brought up that like the sun, it mostly, like everything we talked about, it mostly involved with the sun.
What does the sun give off?
Energy.
Heat. And what's the name for heat?
Thermal energy.
Right? Now we're getting closer. We're getting warmer. If you will. Okay, all right, John, what do you say? Okay, what do we learn about that's related to the water cycle?
The sun.
The sun? Well, so cycles, you could be talking about moon phases,
Tides,
okay,
currents,
which
waves.
then relate to tides. Let's go back to water cycle. Great connections. What else we can do that's related
We learned about
for the water cycle? Liquid turning into gas,
How much water is on the earth?
And gas
Different kind of water.
colliding.
liquids and gases. How does someone determine between a liquid and a gas? Raise your hand. How does someone determine a liquid to a heat?
Heat
Heat.
from the sun.
Heat from the sun, what does it do?
It warms up the water.
What happens when the water on the earth is warmed
It
up?
turns into greenish and
It
it
evaporates, right? What happens when that water molecules cool down?
It goes down.
It
It goes.
condenses, and then,
Condensation.
so we got condensation
And finally, like
and
precipitation.
precipitation. What, have you guys seen something like this before?
Yes.
What,
Convection current.
convection currents. Convection currents. Let's stop and think there. Think. How can we apply convection currents to geology? How can we apply them to hydrology? And can we apply them to astronomy? Nia.
They go like in cycles.
They go in cycles. What's a cycle?
That goes round and round, and don't have a beginning or has an ending.
It does not have a beginning, it does not have an end, like a circle. Okay? How can we apply this thing of hot things going up, cold things going down, to rocks, minerals, and layers of the earth? Science?
Because the heat from the liquid goes up to the
Where does it go?
in class goes up to it's like lava or something.
What layer of the earth are we in now?
The mantle.
The mantle, specifically the
Crust.
the asthenosphere. What's the magma doing in the asthenosphere?
Going
Flowing. Raise it now. How is it flowing? Yeah?
by heat,
By
like,
heat.
but it goes in like convection current
Convection currents. And why do we care about convection currents in the asthenosphere?
because it makes volcanoes.
It makes volcanoes. What else? It makes mountain ranges. What's our theory that says that the crust is moving?
The theory of
Continental drift, or the theory of
plate tectonics.
plate tectonics that Pangea broke up. We got convection currents in the asthenosphere causing plate tectonics, continental drift, Pangea breaking up mountains, volcanoes. That's for geology. How can we apply convection currents to hydrology? Jalen.
Convection currents apply to hydrology because the sun heats up the water which makes it rise, and as it begins, it comes down.
It comes down, right? The water cycle. What's another topic that convection currents relate to in hydrology? Sea breezes. Exactly right, Duran. Well, can we layer in high pressure and low pressure to convection currents?
Yes.
Raise it how? How? Duran, I'm letting you think this. Louder. Go to low pressure air. High pressure, low pressure. Can I put these with temperatures?
Yes.
How?
Because most of all,
One second, Jabri.
because land has a smaller capacity and it heats up and cools down faster than water, and water heats up and cools down.
Okay, so during the daytime, we're having what kind of breeze? Sea breeze. During a sea breeze, what's going to get hotter faster?
The land.
The land. So where is there going to be low pressure air? The land. So where is the high pressure air?
The
The sea. How's the wind going to blow?
It goes from the land
See
to
the land from high pressure to low pressure. That is a convection current, right? Wind. Okay. We got water cycle. Is there a type of storm that relies on convection currents? What? Hurricanes. Where do hurricanes get stronger, Nia?
It gets stronger over warm water.
So do you give me temperature? Yeah.
Warm pressure.
Warm temperatures. Where?
Well, like hot and cold collide.
So that's going to help give me a hurricane and a front, maybe. That gives me thunderstorms. Are you guys starting to see? Nod? Are these things all related? Do you see why Mr. Schneck spent the first 3 weeks of the year doing density experiments? Okay? So, does anyone remember this experiment from the beginning of the year?
Yes.
What's about to start happening?
These will start coming up.
Well, Dominic, the molecule can start spreading. But what is this? This is a what? Hot plate, right? Now what? When I put in these little dots in the paper hole puncher, what do they represent? Raise your hand. What are molecules? Okay. So if I put these in, what are they going to start doing? Make a prediction. All right, turn and talk to your partner. What's going to happen when I put these in here? Great conversation by Donna. Great conversation happening everyone. The random promoter get a great whisper. Okay. 3, back to 0. 2, no one's talking. 1, thank you. Okay. Mom said, what's the prediction of what's going to happen?
It's gonna flow because it's less dense.
It's going to float because it's less dense. No pronouns, Mom Sana. What do you mean by they? Or it's?
The molecule.
The molecules. Guess what? See if it's hot enough yet. Okay. Well, I'll hopefully better carry it around. So this might take a few minutes for it to start working. Okay? Let's see how we do. Okay. Go in your paper. Let's look at your paper for a minute.
The cold, more dense water sinks, and the hot, less dense water rises. So the cold water has more pressure, and the hot water has less pressure because the more pressure is pumped, and the low pressure goes.
Now, one thing that creates our convection currents is temperature, right? Hot and cold. This is taking place in the ocean. What else could you have talked about in your essay besides the temperature?
Pressure.
Not pressure.
Salinity.
Salinity. Where does the water with a high amount of salinity go? Down. Because it's more dense. Great. Let's go back over here. If I take 2 pieces of index card and I rip them apart, okay, what else do we know in the earth is in pieces? Pangea, the crust. These all represent the piece of the crust or the plates.
The plates are
Okay? If I'm going to put these even smaller on top of here, are they going to stay in one place or are they going to move? Why are they going to move?
Because the cold, the atmosphere is going to make it colder to make it go down.
What are these things called in here?
Molecules.
What's the movement of the molecules up and down called?
Convection currents.
Convection currents. So why do we have the theory of plate tectonics?
Because plate tectonics
Because the convection currents where?
inside the mantle.
Inside the mantle. Okay, you guys got it. You guys, eyes here? You guys got it. Does one more person want to read their work?
Yes.
Okay. Here, go ahead.
The cold water, since cold water is more dense, molecules are more dense. From temperature water, it's somewhat spread out. Hot water, since it is less dense, it is separated everywhere because it is separated and evaporated.
Incredible. Okay, great work, everybody. Let's give 2 hands for the people that read the grade degree. 1, 2. 1, 2. Okay, let's go. So here's what we're going to do. We're going to write the best essay that we've ever written. Okay? Because this is your essay, right? And it's things that you know really well. You know what the worst Mr. Schneck can do in school? Write an essay on something that I don't care about. Write an essay on something I don't know nothing about. Right? This is something that you guys are experts on. And it's something that relates to your life. Because there's one thing we didn't talk about. What are some real life examples of convection currents? How can you take this with you? What? Making noodles, cooking food. You guys, when you decide, talk me through that more. What do you?
Microwave.
But then when they start to heat up, when they start
I can buy some.
going like down.
Yeah, you have convection currents.